Hi everyone. So if you can look at, it says write the equation of the polynomial in factored form. So we're just going to go ahead and do the same thing that we've been doing. We can see I've highlighted the intercepts and we're going to write the equation with the factors. So as you can see, we have an intercept at -6, so that would mean x plus 6. And an intercept at -2, so that would mean times x plus 2, times an intercept at +2, so that would mean times x minus 2, and an intercept at +6, so times x minus 6. Oops, 6. And you could see that we have covered the whole equation, so this is correct. Let's go to the next slide. All right, so for this one, we're going to do the same thing, but notice the graph is facing upside down. But let's first enter our intercepts. So we have one at -5, 0, and 7. Notice the graph is passing through -5, it goes up and then comes back down, bounces off the x-axis, and then goes up and comes back down. So let's see how we would write something like that. So we have x plus 5, and then a bounce, which would mean degree 2 at x right here equals 0, so we can just say x raised to the second power. I did put it in parentheses. If you don't write the parentheses, that is fine too. The order in which you write the factors does not matter. And then I have an intercept at 7, so that would mean x minus 7. Now, all our intercepts are matching, but the graph is not facing in the right direction. So if you think that I should have a -1 in front of my a value, then you are correct. -1 or negative is the same. So negative, and there our graph matches. I have an extra parentheses here, so I will remove that. Here's what we call a bend. Do you see how the graph approaches the x-axis, does a wiggle at 6, then continues on the other side? That means a corresponding factor in the equation will have an odd exponent, usually 3. So all that means is odd, so anything that is a degree 3, a degree 5, a degree 7 will have this kind of bend. Normally what happens, the higher the degree gets, the wider the bend is right here, but we will only be looking at degree 3 for now. It says the equation of the graph has a root at x equals 6, so you could see here is 6, 0. So that means it has a factor at x minus 6. But because there is a bend, it means it is a degree 3. So a bend will be where it goes, bends over, goes through the point, and then goes back up. In the box below, write another equation that would have a bend. So basically, you can write anything that has 3 factors at the same intercept. So for example, x plus 1 raised to the cube. That would result in a bend. Write the equation of the polynomial in line number 2. All right, so if you can see at -4, 0, the graph is coming down. It goes through -4, but it doesn't pass through. It bends over. It curves like a snake-like shape. Whenever that happens, we call it a bend, and that is a cubic or a degree 3 factor. And then it will comes right back up through the point 6, 0. So let's try to write that equation. So we have x plus 4. And it is a degree 3, so I'm going to raise it to the third power. And if you recall, raising it to the third power means the little hat 3. So you could see it's going through this point, negative 4, 0, but then we need it to come through the point 6, 0. So we're going to multiply this by x minus 6. And we have our graph matching. Now remember, the order in which you write your factors doesn't really matter. Write the equation, the polynomial shown in line number 2. Okay, so we could see we have a bend here at the point negative 1, 0. It passes through and then passes again through 6, 0. So we have a bend and 2 passes. So our bend is at negative 1, 0, and our 2 passes are 4, 0 and 6, 0. So let's write that equation down. So this point here again is negative 1, so this would be x plus 1 raised to the cube. Anything with a bend is odd degree, in this case 3, and then it passes through the point 4, 0, so we will say x minus 4 and times 6, 0, so we will write x minus 6. And that completes our slide.